In this question, we are given that there are 7 ropes that have an average or an arithmetic mean length of 68 centimeters. So let's write down all the data which we can get from the question. The average length of each rope is equal to 68 centimeters, and the median length is given to be 84 centimeters. We also have that if the length of the longest piece of rope is 14 centimeters, more than 4 times the length of the shortest piece of rope. Now, the longest is equal to 14 centimeters more than 4 times the shortest. We have to find the maximum possible length in centimeters of the longest piece of rope. So basically what the question is asking us to do is to find the longest length, but we have to maximize it. Now that we have written down all the information that we can get from the question, let's move on to step 2. Now, since we are given the medium, we should have the 7 lengths arranged in ascending order. Now, let's assume the 7 lengths to be n1 less than n2 less than equal to n3 less than equal to n4 less than equal to n5 less than equal to n6 less than equal to n7. Now, according to the given information, n7 should be equal to 14 plus 4 times n1, which is the shortest rope. Now let's understand how we can maximize the length of the longest piece of rope. Now if you want to maximize the longest piece of rope, we need to have the other quantities in the reduced form or in the lowest form. And we also have to keep in mind that the median of these 7 pieces of rope is equal to 84 centimeters. Now we have information about the longest and the shortest one. So let's assume the first 3 data points as n1 plus n1 plus n1. Then, since there are 7 pieces of the rope, that means the 4th term will be the middle term. Then we can take the other 4 terms as 84 plus 84 plus 84. Now this is equal to 6 and the last term is equal to 14 plus 4n1. This should be equal to the total length of the rope. Keeping this in mind, we move on to step 3 and calculate the maximum possible value of the longest rope. Now, using the equation we have written in step 2, when we solve the equation, we get 7 times n1 plus 266 equals 7 into 68 centimeters. Since 68 is the arithmetic mean and there are 7 pieces of the rope, this gives us 7n equals 7 times 68 is 476, and we subtract 266, which is equal to 7n equals 210. This gives us the value of n1 as 30. So this length of the smallest rope is 30. So the maximum possible length of the longest rope is equal to 4 times n1 plus 14. This is equal to 4 times 30 plus 14, which gives us 120 plus 14, which equals 134, which is our option D.